In this problem, we continue to play a little bit with the outer measure. So in the first one, which by the way we saw something similar before, is that if the outer measure of a subset A is equal to 0, then we have some kind of additivity of the outer measure. Okay? Okay, so we want to show that the outer measure of A union B is equal to the outer measure of B. Okay, easy. So what do we have? We have the monotonicity of, since we have B, which is included in A union B. Okay, so by monotonicity of the outer measure, we know that the outer measure of B is less than the outer measure of A union B. And now, using the sub-additivity of the outer measure, this is less than the outer measure of A plus the outer measure of B. Knowing that the outer measure of A is equal to 0, this is equal to the outer measure of B. So what do we have? We have the outer measure of B less than the outer measure of A union B, less than the outer measure of B. Therefore, they are equal, which proves our claim. The second problem is a little bit trickier. Okay, so what do we know? So we want to show that there exists for any E subset of R, there exists G, which is a G delta, such that E is a subset of G and the outer measure of E is equal to the outer measure of G. Okay, so remember that a G delta is an countable intersection of open sets. Okay, so it's a Boolean set. Now, so what do we do? So first we have to go back to the definition of the outer measure. We know that for every epsilon, there exists a sequence of open bounded intervals such that first of all, E is in the union of the INs, and that the outer measure of E is less or equal than sigma of the length of the INs less than the outer measure of E plus epsilon. Okay? So what we are going to do is we are going to take epsilon to be equal to 1 over n for n greater than 1 and set g n to be the union of these open intervals. Here I couldn't say because you already here, so let's say it's k of n because it depends on n. Okay, so what do we know? We know that Gn is open because it's a union of open intervals. We know that the outer measure of E is less than the outer measure of Gn, less or equal than the outer measure of E plus 1 over n for every n. So now let G to be the intersection of the Gn's. So this set is a G delta because it is a countable intersection of open sets. Now what do we know? We know that E is a subset of G. Therefore, by monotonicity of the outer measure of E will be less or equal than the outer measure of G. And since G is included in Gn for every n, we get that the outer measure of G is less or equal than the outer measure of Gn, which by itself is less than the outer measure of E plus 1 over n. Therefore, the outer measure of G is greater than the outer measure of E, less or equal than the outer measure of E plus 1 over n for all n greater than 1. Obviously, this will imply that the outer measure of E is equal to the outer measure of G.